Hello learners, today we will be discussing about how current conduction happens in the metal conductors. As we know that every metal conductor has large number of free electrons. What are the free electrons? Free electrons are those electrons which are very loosely attached to the nucleus of an atom. Electrons in the inner orbit close to the nucleus are tightly bound. As we move away from nucleus, the binding goes on decreasing. So electron in the last orbit called valence electron are very loosely bounded and they can be easily removed. These are free electrons. Every atom possesses free electrons and they wander within body of the conductor like molecules in the gases. The average speed of free electron is sufficiently high at the room temperature. During random motion, the free electrons collide with positive ions, those are of metal, again and again. After each collision, their direction of motion changes, and when we consider all the free electrons, their random motion average to 0. In other words, we can say that there is no net flow of charge in any particular direction, and hence no current establishes. When potential difference is applied across the ends of a conductor, let's take copper wire. Electric field is applied at every point of copper wire, and the electric field exerts a force on the free electrons, due to which they start accelerating towards the positive terminal of the potential. As free electrons move, they collide again and again with positive ions of the metal. Now you must be curious about what happens to an electron after collision with an ion. After collision, it moves off in some new and quite random direction. However, it still experiences the applied electric field. So it continues to accelerate again, gaining a velocity in the direction of the positive terminal. It again encounters an ion and loses its direction motion. This situation is repeated again and again every time. Each collision destroys the extra velocity gained by the free electron. The average time that an electron spends between two collisions is called relaxation time. Although the free electrons are continuously accelerated by the electric field, and collision prevents their velocity from becoming very large. As a result, electric field provides a small constant velocity towards positive terminal, which is superimposed on the random motion of electrons. So this constant velocity is called drift velocity. The average velocity with which free electrons get drifted in the metallic conductor under the influence of electric field is called drift velocity. This is the order of 10 to the power minus 5 meter per second. Drift velocity is responsible for electric current in metals. Now you must be thinking that if electrons drift so slowly, how room lights turn on quickly when switch is closed? Because the propagation of electric field takes place with the speed of light. Thank you for being here.